Uh, Thank you, Diego. Yeah, I will be presenting for you the FFT contribution for the uptime use case, which is also part of the 4C cluster. Um, and our use case is regarding predictive maintenance of complex mobile assets, which is a little bit different than probably than what we have seen until now. First, let me present to you uptime in a nutshell. My colleague from Whirlpool Pierluigi has already presented a little bit about this in the first webinar, but this is especially for uptime. The uptime project has 11 partners, 3 use cases, and 1 unified platform. And as you can see in the map also, it's a European-wide project. And what is interesting in the uptime project is that all the partners you see in a group with BIBA, so that's ICCS, UBTEC, RENA Consulting, PwC, and Suite 5. They take care of the implementation of the modules of uptime and the integration. And then we have the 3 use cases by Whirlpool, Mylis Group, and FFT. And then we have also for the marketing and innovation management, we have Muse and Isadeus as partners. So this is a very nice consortium where we have a lot of different skill sets, and we are integrating this to leverage these skills in the uptime project. What is the uptime vision? The uptime vision is basically to take the big advances of 3 big scientific fields: Industry 4.0, big data processing, and proactive computing. We are basically, with our quite large consortium, leveraging, exploiting the advances in these 3 areas, and trying to make it, it's a really key issue, make it a unified platform, uptime, to take advantage of these things in one platform. And that is what you will see later also, whether we succeeded or not. That is what we will present to you in the later stages. But first, I will have to set the stage. What do we do? FFT in a nutshell. FFT is basically a turnkey automotive production line provider, who normally acts as a general contractor in big projects. But we have also, so this is basically what you can see on the left side here, automation technology in automotive. And we also, and this is also where I am active and have been active, it is system and test operations in aviation technology, and also production technology in the aviation sector. So as you can see on the right, top right picture, that's a full-scale high-lift test rig, and in the right you can see the C919, which is the Chinese civil aircraft. And of course, and this is what the uptime project is about, also it's maintenance. And also, in this respect, FFT is a little bit different from other cases we have seen in this cluster, because it is not so much factories that do their own maintenance for their own equipment, but it is basically maintenance under contract in most cases, because we, for example, production lines we have built, or assets, equipment we have built, we can provide maintenance for that, but we also do contract maintenance for complete factories, even if we haven't supplied any equipment in these factories. Our specific use case for the uptime project is that we have large mobile assets. They can be seen on the top right on the picture. It's a very big transportation jig, which is used to transport wing panels, wing skin panels for Europe's largest aircraft OEM, and it is quite a challenge, as you can see, not only the transport itself, but also to provide the jig and to keep them transport worthy. In this case, we have actually also built the jigs, and we completely separate from that project, supplying the jigs, we perform the maintenance for mobile transportation jigs. Not only this type, but this type is the scope of the maintenance project which we do, in which we use UPTIME as a pilot case. The maintenance of these assets is extremely crucial, maybe even more so than inside factories, because if they are not airworthy, the chain stops. They are not allowed to fly, and then you impact the whole production chain, and it's also a huge safety issue if something happens to the jig in flight. That we can all imagine. And because the assets are mobile, there's an extremely high coordination overhead. Because you don't always know where they are and when they will arrive, and the turnaround time when they have to leave again, and of course, because it's maintenance under contract, we also have quite a high reporting overhead, because you have to basically report all the summary from your maintenance performance to the customer. So then summarizing the challenges which we therefore see in our use case, as I already mentioned, we have an extremely high effort to ensure the operational reliability of this type of jigs, because they have to be airworthy, and you have to do a check on every loading or before every loading onto an aircraft. And because these jigs are large and subject to environmental harsh conditions, there's actually quite a high effort for corrective maintenance and also preventive because of safety. What is also a challenge is that you never know what the essence status is when it is in transit. So and it is in transit for a few days, but it will come back to the base where you do the maintenance maybe every 10 days or so. So in the meantime, you cannot really rely on a few operators. You don't have direct contact to them. So it's a very big challenge to tackle. And of course, high availability requirements. For example, the jig arrives, is unloaded, and has to go back immediately or as soon as possible. Flights are scheduled, trucks and ships are scheduled for transporting it, and then they have to get back and be loaded again. So this is a very fast turnaround time which is required, and you have to be able to plan for that. And of course, the last few challenges, mishandling, as I already mentioned, you have operators, factory workers who load it and unload it, and nobody else is in the vicinity, so you have no way of knowing what happens to the jig. And last but not least, the issue of no feedback is significant. There is no feedback from the maintenance team to the design team, and this is maybe not a usual case, but it would help a lot if it were there, because FFT is the supplier of the jig in a separate project and the maintainer of the jig in another project, and any elements that could be needed or that could help to limit the maintenance effort should flow back to the engineering team and to the supplying project. If this is for free due to good information platform, that's a huge bonus, of course. So what are the typical failure cases we see for this type of asset? Structural failure, welding seam cracks, water, ice. You can imagine, especially water and ice is a huge problem if you go up high in the air. The aircraft is not pressurized and not temperated, so you have, if there is ice, it can really do damage to the structure. So this is a huge issue. Overloading can happen, user error usually. Collisions, also user error, forklift trucks that crash into the jig and nobody notices, except for maybe the people who did it, but nobody else is in the vicinity. Corrosion and aging, of course, which we all know, especially for mobile assets. And lost parts, things that are detachable and can be lost by users during loading, for example. Especially typical causes for these type of failures are dynamic loading, shaking, vibrations, obviously environmental stress, temperature fluctuations, humidity, and so on. And of course, user error, as I mentioned. So what was the status quo of our project in 2017? That was basically to be attracted to us. We have, before we used to do only planned preventive maintenance and corrective maintenance. We have a very high dependency on customer production processes, so you have to be very flexible. Basically, if the customer says do this, you have to be available in order to get your customer satisfied and to reach your KPIs that he has defined. We have a very high manual effort of asset identification. It's basically paper-based. And so the usual lists and reports and phone calls and so on. This is very cumbersome. You don't know where the asset is and what the condition is before you took a good look, did an inspection. And as I mentioned before, there's this feedback topic. And the assets basically wander through stations to production site of the customers. And the maintenance has to be done at one of these sites. Now, for example, in northern Germany, when the jig arrives, the team is dispatched. It has to drive 1 hour, and then they can do the maintenance. So this is also something which can benefit a lot if you can have better planning. What are the typical KPIs? I think we all know this. We don't have to. It's because it's typical for maintenance projects in general, I would say, and production projects in general. I won't go in detail, but you have to be on time, have to maintain your quality, and also be within your budget or cost range, of course. How can we better reach these KPIs? This is what we while entering the project. By being much more flexible with planning and integration of the processes, and this could benefit really from a planning tool. You have to have a continuous information management, which basically also follows from that. But it's more, and namely, you have to, especially to prove that you have done the maintenance and to see what you have done before. You have to document very carefully. You have to be very transparent to your customer because they know that you did your job basically. And this is how do we report this? This is a big effort, and you have to, of course, somehow, if you want it continuous, you have to have some way to measure the asset condition other than just at regular intervals do inspections. So, and then of course you can reach a continuous improvement process, which is a big enabler again to reach your KPIs continuously and to solve the weak areas. Through the scope definition, because it basically really sets the stage of how we co-developed uptime and how we facilitate uptime to know what is needed in industry, and especially for our use case, obviously. So what we need is a good way to get asset health data and evaluate it and manage it in one unified platform. That is so that all stakeholders can access it in a good way. So this in post-processing and storage of this data, and also capability to manage comprehensively the maintenance process, meaning again all stakeholders. So you have the blue collars and managers and everybody in between. They need to be able to manage this process. And of course, because it is not just this asset, but it can be any asset, you have to have open interfaces to basically be able to use it in any maintenance project of this kind. And that prompted us also to say, basically, also we need a physical asset data acquisition platform, basically meaning a sensor platform, which has this capability to do it in a mobile way, measure many different types of quantities, scalable and easy to use. And so that is all quite logical, but mobility is key here, and it's not something that in many other projects plays a big role. And of course, it has to be certifiable for in-flight operation. This is also a typical issue. You know that you have to switch off usually your phone, and if this IoT platform has to be switched off, it has to do this in a certifiable way. So this leads us. This led us as FFT, as a participant in Uptime, to this concept we see here. This is basically the vision, what we promised ourselves from Uptime as a top level concept. You can see here that we have the sensor platform I was just talking about, the data acquisition platform, which is really IoT type. You can see many sensors, and in our vision, this is each sensor is really just an IoT thing which you can slap on equipment, and it will do its thing. Gateway, which is a semi-mobile hub, basically for that. And of course, you have a way to introduce manual data also in your platform. And then the platform is the big blue one here, and it should obviously then support all the things I mentioned before, meaning storage, the whole maintenance process cycle with plan, do, react, act is the short form. Here you can see it. And this should all be supported by the maintenance platform. Very significantly on the right side, you see the interfaces. The stakeholders, if you can manage to get all stakeholders of your project to have specific type of access to your data, basically means that you don't need to do any reporting anymore, or the system does its own reporting. And this is something which we promise ourselves a huge benefit from, because this is a very large part of the maintenance effort is the reporting by the maintenance coordinator to the customer, for example. And the other thing I mentioned, if the engineering team could look into the assets here, they could see, oh, this thing is always breaking down. Maybe we made a wrong design, for example. So this is a very powerful topic. So this is of course the nice tangible part, which we also partly contributed to the project. It's the development of this sensor platform together with BIBA. So BIBA was in charge of the gateway, and we were in charge of the sense nodes. We call it sense node and sense core. And here you can nicely see the evolution of the product through the project. And you can also see, I will get into that in more detail, what position this part, UPTIME Sense, plays, what role it plays in the complete unified UPTIME platform. It is here the small yellow area. So here in a bit more abstract way, it's basically how the UPTIME platform is applied to the FFT use case, and this is something which is specific to us, and the other use cases lay more focus on different areas of different components of the UPTIME platform. Generally, you can see it later in detail. Just watch the video and pause the graph, I would say. But generally, this just depicts the whole information flow within the UPTIME platform, and this will play a role. And that is here the complete UPTIME information platform. This is the sense part, which for us is specific. For others, they may use their own sensors for their factories and just enter the system here on this boundary. And this combination is the specific implementation of UPTIME, the specific deployment of UPTIME in our project. Just a quick fact sheet, because that gets us basically to where we want to get the data, right? So how does the platform let us interact with the data? So in this case, we have instrumented in a few campaigns, and it's unfortunately not yet continuously possible. I will say more about that in the conclusion. So what we did here is we instrumented the jig with these sense nodes and used it for part of a transportation cycle. And that has then delivered the data to our UPTIME platform, which then can be used to analyze it and to work with it. And that's where we get to the actual data analytics. This is real-time data analytics. Indeed, the gateway we did in some test situations did also measure real-time GPS position and posted this data as through LTE. It is also possible to use it in a batch-wise manner, but and this is what you can see here is the interface. Sorry.
Yeah, Jeroen, sorry, I lost you again when you were speaking about the LTE.
Okay. What we see here is the stream data analytics, which basically means we are measuring real time or continuously, I should say, the data being posted over LTE from and here you can already see interesting that this is part of the data which is measured, acceleration in this case, and orientation and so on, and GPS position on the map. And then you have here in predict, you have already a processing which does outlier detection and trend analysis and so on. And then you can see here already forecasts about your asset. Especially the live view, which you can also present, for example, to customers, factory operators. They can see, oh, is the jig stuck somewhere? Why isn't it moving? Why isn't it coming to us? And when will it arrive? They said it would be this time, but maybe it's later. And everybody can better plan for that, which is currently, or before this, has not been possible. We can also do batch data analytics. It's basically separated here in the platform, stream data for continuous data and batch data analytics for batch data. And these are typically the batch data. This is typically the information which comes from the inspection reports, which means it's semi-structured data. Which is imported. There's a tablet-based checklist kind of system, which can import all the observations of the maintenance team, and is imported. It is basically, it has free form possibilities also inside. So it means we need some semantic analysis to get it a little bit more quantified. This might change in the future if we can, for example, implement an app which people can use on their phone or tablet, which is integrated in UPTIME. This has been done, as far as I know, in the Whirlpool case. So this is already in the UPTIME project. Here we are still in batch data analytics, where you can see also that it plays a very good, a very important role for the stakeholder information access. So as you can imagine, this summary data about maintenance inspections and so on is very good for many stakeholders, for example, to perform trend analysis, priority identification for a maintenance coordinator. What happens more often? What is more severe? Where do we need to improve? What is the correlation between certain failures we see? For the engineer, it can serve as hotspot identification. Which type of failure happens most? And is it jig specific or not? Is it maybe related to environment, whatever? And of course, the owner operator, which is in this case our customer, they can also sleep better at night if they have permanent access to such a dashboard where they can just go in and see, okay, we are on track, and we don't need extra reporting from the maintenance service provider. So this is basically what satisfies that very important need. Since we are here, an important topic of this webinar is also ROI. I have to apologize. We are not yet so mature that we have a full-fledged in-field deployment, and therefore we also don't have real data pertaining to ROI. But we have here kind of a projection of what could be possible. We might recall the special features of the FFT use case. We do it as maintenance as a service, which is a bit different from many other 4C cluster use cases. We have mobile and diverse assets, dynamic scope. What is the fleet of assets? It could be also added or reduced or different. And we have an additional layer basically of end user type stakeholders, meaning our customer is one of the end users of the platform, but the maintenance team and the maintenance coordinator would be another type of, which could also be called an end user. So if we now recall the main points of focus, maintenance planning is a very significant issue, maintenance execution, reporting, and continuous improvement of the product and the process in this case. So referring to these 4 main points, then the question how to project ROI becomes how much more efficient are we doing or are we expecting to do these points by having a platform like us. And therefore we have here on the right, you can see, I will not go into the numbers, but just roughly you could basically imagine if the maintenance team can better plan when they have to go there. They know what tools to take because we already know something about the health of the asset and when it's coming. Then we could save a lot of waiting times, wrong deployments, forgetting tools, ordering a certified welder, for example, in advance. And that could calculate down to a higher efficiency, meaning you can use your maintenance team to do other stuff instead of waiting if you don't have enough information. Yeah, for that I can only offer you a ballpark, let's say 15% reduction of personal costs for these type of assets could be attainable. What is not factored in yet is the performance opportunity cost, meaning basically how can you win more projects or extend the project because your performance is so good. So the customer wants to do more with you. Customer cost saving, of course, it's also a type of cost saving. And generally the opportunities, because your quality of service can be increased. So basically this only mentions the return, not the investment. So ROI would also include investment. It's difficult to say at this point because uptime doesn't really have a price tag. So of course you have to consider the effort of training, deployment, depending on how the technical sense requires consultancy fees and so on, license fees. It's just a very rough estimate, but you should be able to earn it back in 1 or 1.5 years for up to 15 persons in the maintenance team. And it could obviously be better if the size is bigger because you typically gain more from the management efficiency you get through using such a platform. So end user assessment feedback, I will give you some. They are partly also projected, or basically we as deployers are playing the user at this point. And we don't have hard numbers from actual maintenance teams using this tool yet. So you have to perceive it like this, the background of these assessments. It is a very intuitive platform with a nice web interface, and it's basically is successful in the goal of giving you the asset data at your fingertips to access on demand your asset data, the health data. For the platform, the configurability and the customization within the platform could still be improved. Basically meaning that you would hope that domain experts could do configuration tasks for this platform without needing to do programming or raw data access or things like that. For the sensor platform, I think it's a really nice product. It's almost a product. It's a prototype product because it supports instrumentation on the fly. You could sell it as a small box and just slap it on some machinery and use it, do measurements. And of course, plug in strain gauges and so on. This is all featured in this in this hardware. So this could really be a product which you can sell by itself, and which we as a system integrator can also use in our project. The utility of the, as I already mentioned, you have on-demand access for multiple stakeholders. That is really a big bonus. It's really useful to minimize reporting overhead. It delivers planning input automatically, also because it's on demand, so you just get it when you need it. And it enables continuous improvement. Because you have continuous data, you can identify issues which you need to solve to improve. So the impact for the end user, it's basically takes all the TS management information handling away and makes you focus more on your core task. And it induces less waste. This is basically the main topic which I already mentioned on return on investment. So you can plan better, you don't need so much improvisation. What are the lessons learned? One big lesson I would say, which is up to now, it's still challenging, is that these assets we have in this pilot deployment, meaning these transportation jigs, they're owned by FFT, they're not owned by us. And because of that, we are limited, especially due to the COVID-19 situation, in doing everything we want in terms of flexible deployment. Just do a trial, field trial, second field trial, and so on. So this is one of the biggest lessons. I would say it is not optimal to do a pilot deployment in such a use case on equipment you do not own yourself. What is further important for what we can see, especially in the platform, is early integration. I think we have worked within the Uptime Consortium very productively together and in a very pleasant way, in a very effective way. We might have focused more on integrating earlier and just having more touch points during the development, and not just basically develop a component and then look how to integrate it. I think we could have stayed even better on track if we would have done that earlier. Next step from FFT perspective would focus on partial deployments, including focused improvements and partial deployments. I mean, of the Uptime platform, basically choose a few components for a certain use case, a new use case, and then only apply these and not use other components which are also part of the Uptime platform, and then do focus improvements on these parts, on these components. I would also say it's very good for both parties that we can add uptime to the toolbox we have, to the basically also the references, but also actual tools we have at our disposal to get further service projects. So both service and turnkey can benefit from this for a company like FFT. We can just do what we always did, but we add as a unique selling point the option of using uptime to get the customer to see better data and to basically also be able to put, for example, their measurement system inside the project using uptime. So this is a very nice addition to the toolbox. Relevance to European manufacturing industries is mainly that I think that uptime has a great potential to significantly lower the barrier to deploy such a solution as an integrated maintenance management platform in their current business. It is not off-the-shelf product. It's not such a mature project yet. but it is already very possible to do a further project of integrating this in the current workflow. And you know what you have already a little bit. So this lowers the barrier to make this step for many companies, I would say, potentially. That's my own opinion in this case. Yeah, that brings us to the end. I want to make a quick introduction to the third webinar we have. It's on the 10th of December, and it will go into more detail into things I told you. So you're welcome to join on the 10th of December from 11 to 12:30. That would be all from my side. Thank you very much for your attention. And of course, if you have any questions, you can contact me here or ask the questions at the end of this webinar, of course. Thank you very much.